2016-17 school year was an exciting time for mathematics instruction. As a team, we embarked on the journey of implementing Math and Focus as our core curriculum in grades K to 8. We are so thankful to the entire Radnor community for their support in this initiative. The school board and Radnor taxpayers supported not only with approving the implementation, but also supporting a highly robust professional development plan, which proved to be invaluable through this process. I would be remiss if I didn't acknowledge the incredible efforts of our teachers and support of the building administrators. Across the district, teachers embraced the change and we traveled this path together. Teachers have spent countless hours working collaboratively to plan engaging and challenging lessons, analyzing data, and growing professionally together. One of my favorite quotes is from Robin Sharma, who said, "Change is hard at first, messy in the middle, and gorgeous in the end." This is exactly what we saw, and we are a stronger district because of it. As a result, we are experiencing students who are willing to take risks in mathematics, checking their work and being attentive to detail, and solving complex mathematical problems that are relevant to real life. I'd like to share with you the story of the butterfly from an unknown author. One day, a boy found a cocoon of a butterfly. As he watched it, he noticed that a small opening appeared. He sat and watched the butterfly for several hours as it struggled to squeeze its body through the tiny hole. Then it stopped, as if it couldn't go any further. So the man decided to help the butterfly. He took a pair of scissors and snipped off the remaining bits of the cocoon. The butterfly emerged easily, but it had a swollen body and shriveled wings. The boy continued to watch it, expecting that any minute the wings would enlarge and expand enough to support the body. But neither happened. In fact, the butterfly spent the rest of its life crawling around and was never able to fly. As the boy tried to figure out what had gone wrong, he learned that the butterfly was supposed to struggle. In fact, the butterfly's struggle to push its way through the tiny opening of the cocoon pushes the fluid out of the body and into its wings. Without the struggle, the butterfly would never fly. The boy's good intention hurt the butterfly. I share this story as a reminder that struggling is an important part of any learning experience. In fact, it is the struggle that causes you to develop your ability to fly. Let's look at our journey together as we learn to fly with mathematics.
Comprehensive, rigorous, and rewarding.
I would say problem solving and thinking.
Yeah, I would have to say challenging but rewarding.
Exciting, frustrating, challenging.
Challenging, problem solving.
Concrete, pictorial, abstract.
Language.
Challenging.
Hands-on.
Students as mathematicians. I think Math and Focus builds towards algebra readiness because it has the students start to formulate equations without using the term equation, and they're able to put it in context. So it's building the foundation with which the children are able to build upon to move forward with algebra concepts. So it is a challenging and complex task, but the kids are really seeing the rationale behind why they're doing something, and they can see how it fits together when they're going to put together an equation to figure out some unknown variable. They're not just looking at x plus 4 equals 10. They're really breaking it down into what that particular x means. So they see the meaning behind it.
What we see is that I think at the younger grades, they put a lot of great pieces in place, a lot of good strategies for creating number sense and algebra readiness by teaching the kids the number bonds. And the number bonds make their way into bar models. And bar models are just a step away from creating equations and algorithms. And it all fits together very neatly. They've been finding the area of the trapezoid hasn't been a problem. Now we're going to remove the height and give them the area. So now we're getting into that algebra readiness of solving for a piece of the puzzle that's not always just finding the answer, finding a part of the question.
This program really is asking the kids to be problem solvers. It's asking them to use math and to be thinkers. We just so happen to be using numbers in first grade to try to solve these different problems. So it doesn't box the kids into any one particular strategy. In fact, it asks them to use multiple strategies to solve the same problem. And so there are a variety of unknowns in each problem, which sort of builds toward that, pre-algebra, algebra readiness.
At the beginning of the school year, I noticed that Math and Focus covered algebraic concepts very early on in the curriculum. I feel that it's really helped the children to understand the concepts a little easier and to help prepare them as they travel to the next grade.
And then working with fourth grade, it's more of, applying what they've learned. It's not just here's your answer, it's why did you get your answer? The thinking behind getting your answer. We always tell the children, in third grade and as well as fourth, it's not enough just to give us the answer. How did you get to your answer? How did you arrive at your answer? And then for them to actually start thinking about, the process of, okay, the answer's 32, but why is it 32? Why? And then putting a unit there, they're doing more thinking about math rather than almost memorization to it.
Yeah, and since the program is so language-based, the children have really developed math terms, and they're able to talk about math a lot easier and a lot more thoroughly.
The way I see our fifth grade students using this as an algebra readiness is the way that they keep problem solving and coming up with different ways also gives them a good idea of how many different equations they could come up with as they're trying to solve the problem. Where would the variable be? What is it that we're trying to find out? So it's a wonderful leeway into algebraic problem solving.
The use of manipulatives has been great. The whole CPA, concrete, pictorial, abstract, has been phenomenal. If you just tell somebody to do it, they forget, show them, they remember, but if you get them involved, they completely learn it and remember it for a lifetime. The whole concept of being able to touch the materials, to be able to draw the pictures, and then be able to do the algorithms just kind of ties all the pieces of the puzzle together, especially since it's a variety of learning techniques. It really seems to hit home, and you might miss kids on one learning technique, but it seems to completely kind of tie everything together towards the end once you've introduced all aspects.
Students using manipulatives helps to solidify concepts that are abstract, and it also helps when introducing new concepts to students because they are able to first start with something concrete and move beyond the concrete to the abstract. They usually make a quick progression from using the manipulatives to being able to use the formulas and equations and more complex methods of solving problems.
The manipulatives help the students get a mental picture of the concept of, say, place value. So when they can put the coins in the place value chart, it helps them to visualize the problem completely different than the textbook or the copybook. Then they can transfer that understanding that when they can regroup what it really means, more than 10 goes to the next place value. So it helps them understand a concept. Often they'll retrieve that picture in their head when they're doing the pencil and paper work.
Using the CPA approach is a natural approach I feel that teachers enjoy using in the classroom. We start with a concrete manipulative usually, then we head into the book and look at the information that's provided by the program, and then we set the children free in the classroom to work on the abstract.
They're independent thinking. Applying what they've learned and then going from concrete to pictorial and then
to the abstract
thinking.
One activity we used to start with concrete and move to pictorial and eventually to abstract is the idea of creating zero pairs when you're adding and subtracting positive and negative numbers. So what we started with is having the students recognize that the yellows represented positives and the reds represented negative integers. So if we were going to do something like 4 plus 1, it would be as simple as saying I have 4 positives and I add 1 positive and now I have 5 positives. But if we were going to do 4 plus negative 1, what we can show through this is that if I have a negative, I can create a zero pair. These become a 0 and all that's left behind is the 3. If I was going to take that into pictorial, what I could show is that I have, for positive numbers, I have 3 positives and I have 1 negative. So what's created from there is 2. And eventually what we make our way to is that 3 plus negative 1 is the same as 3 minus 1, which is 2.
As far as elementary school students go and abstract reasoning, in the 5th grade, we have gotten, at least as far as as elementary students go, to the most abstract level of their mathematical career so far. What I'm finding about Math in Focus is it is really giving students a great place to take that abstract and make it concrete and then back to abstract. The bar modeling is helping them give them a vision of what the problem is actually asking so they can be concrete and then go to the abstract algebraic equation that they could create to solve the problem.
Instead of giving them a bag of tricks, I want to give you a box of tools. They're learning tools. And that's why I have my math toolbox now in their group. Anytime we add something in today, they can refer back to it because now it has a base, it means something to them that they can use.
As far as precision with my students, one of the things that they're really realizing is the importance of accuracy all the way through problem solving. Because since the problem no longer stops with the first step, if they make a calculation error in the first step, then it's going to continue to throw their answer off so that by the time they get to the final answer of the equation is askew from what the actual answer is. Where if they're precise at every single step of the way through the problem solving, they have a much better chance of getting the correct answer at the very end.
No, yeah, there's a 200 in the sample space, but not in the spinning.
I think the best part about Math in Focus is how students discuss math. Students' conversations are much more in depth and they are applying mathematical vocabulary and actually talking like mathematicians when they are having discussions in groups. My favorite part of Math in Focus is watching students complete the anchor tasks. Although they can become frustrated at first with the anchor task and often say, I'm not sure how to solve this problem, once they start having conversations and dialogues, they really engage in deciding whether or not they have enough evidence to support their reasoning. They go back and they review materials that we've used in class to help them to understand whether or not their thinking is correct. And they are often able to find their own mistakes now. And it's nice for students to be able to find their own mistakes because then I feel like they understand the mathematics concepts better.
The student dialogue has improved tremendously because of the problems being a little bit more in-depth, richer, and with several parts. The students really have to talk it out. They have to take it sentence by sentence to determine what the question is really asking them. We've spent a lot of time on that, but it has paid off in the end because they're much more careful about finding out what a word problem is asking them, not just assuming what they're asking.
They're using the language to math. They're using math terms and they're using the definitions and then being able to explain it. But not only are they doing that, they're using at home if there's something that is connected to the math lesson that we learned. They're like, Mom, Dad, that forms a right angle.
I think that, especially on the assessments, they have the real life problems, the extended responses at the end of the math test. And it's kind of exciting to hear the kids come in, the next day and say that, oh, I was able to make a connection like the real life problem at home, and they're really making those connections with math in the real world.
When I ask them to talk in a group, they're never off task. And that's something I haven't seen before because I think they see the discussion as a challenge. They see it as like they're solving a puzzle, they're solving they're solving something that's complicated and they're trying to put together their ideas to create an answer. And as opposed to having them just answer questions, this is more like a game to them. This is more like a challenge that they're trying to overcome.
I think as kids have become more involved with using manipulatives and moving from that concrete to pictorial to the abstract, I've listened to the dialogue that they've had in their team groups, whether they're partnered up or with their full group of 4 or 5 children. And when I hear kids who are answering with a more in-depth response, I think it propels the other kids forward. And so there's a learning trajectory because of group work with this program.
The complexity of tasks is challenging for students at first. However, after the students become engaged with Math in Focus, they adapt to the complexity of the tasks. In fact, my students often say to me that everyday math was not challenging enough, and that's why they like Math in Focus. The complexity of the tasks, there's often multiple steps to the problems, and what they are asked to do in the first part of the question, in the second part of the question, it builds upon that knowledge, and it also builds upon previous or prior knowledge that the students need to break down, and they need to think about it in the real world, not just regurgitate information back.
The complexity of the tasks that the students have to go through, it goes back to the CPA approach of you have to start at the very basic with the concrete, and then you have to build from there. Because in the very beginning of the program, it was a steep learning curve for the teachers and for the students in terms of, they not only had to come up with their answer to explain why, and it went from one-step problems to 2, 3, and 4-step problems, and then even in the upper grades, it gets very complex very quickly. So they have to learn to apply what they learned in the very beginning to the middle and almost to the end for the concrete, pictorial, and then the abstract, to apply what they're learning in the classroom.
Mm-hmm. But I think we're able to differentiate pretty easily. Even though the tasks are very complex, there's enough information within the program or enough material that we're able to differentiate from the get-go to meet the different needs of each child in the classroom.
So look at a question like this. We teach ratios as that the ratios of boys to girls in a class is 2 to 3. If there's 20 girls, how many boys are there? So they learn that the 2 to 3 represents 20 to 30. So now I have 20 girls and 30 boys. But then we take the next step of it. If there's boys, girls, and teachers, and there's 25 teachers, can we break that down and find out what a unit is? And then taking the next step of a problem like this, where it says the ratio. So now you use the ratio to find those pieces, and then you take the next step and apply it to something like finding the area of a trapezoid. That's a perfect explanation of that. They learned very basic ratios, and then from the very basic ratios, they learn more complex ratios.
Okay, so I drew out the bases and the heights. So I did base 1, and that was 2. So I drew out 2 boxes. And then for base 2, or that was base 1. For base 2, I drew out 3 boxes. And for the final one, which is the height, I drew out 5 boxes. And so it says that the height was 25 inches. So that must have meant that all the units, 1, 2, 3, 4, 5, you do 25 divided by 5, and you got 5. So all of these are 5s, all the units. And so that would mean that base 2 is 15, and base 1 is 10. And first it says you have to find the 1/2, so I did 25 divided by 2, and I got 12.5, and then I added those together and I got 25, so I did 12.5 times 25, and I got 312.5.
And so I know that one side is 24, so I figured out a quarter of 24 is 6, and so I know that the height of the triangle is 24 because you can see that it goes from here to here.
And here it says that this is 12, and it breaks up into 2 spots here, and each of them is 6, and it shows that these are equal to these, so these are each 6, which means that this is 18 and this is 12.
So there are many different ways to solve a problem. The specific problem is finding the base of a triangle. So let's say that the area is 36.5, we know that, and the height is 10. What you would usually do is you would do area is 1/2 base times height, then would find the height, and you would divide it by 2, and then but I did it something differently. What I did is, since 1/2 is in reality just dividing by 2, And the inverse of that would be multiplying by 2. So I multiply 36.5 by 2 and get 73. Then what I do is I realize that 73 is just base times height without the 1/2. So I plug in the 10 and I divide by 10 and I get that the base is 7.3.
What I like most about math is how you're solving the problems. It's like you're solving a mystery almost.
I like that math challenges me if there's something that maybe is a little bit hard or has something that has a lot of steps, that if I never want to give up, because once you get like the final answer, it feels like you've like accomplished it and you can get it, and it feels like good that you did it.
I love playing games of math because we get to work with different partners.
What I like about math is fractions because I like adding them, and we have circles and we get to put little pieces and make our own fractions.
I like math because the real world problems really relate to real life.
I like how you can learn new things and it's fun to be challenged by it.
I like math because it makes you smarter.
I like how it's challenging and the words, like how they word it, it's different, so you have to like read it a couple times and think about it.
Making line plots and bar graphs because it's fun to like make them up.
I like long division because it gives you an easy way to solve big division problems.
What I like most about math are the problem of the weeks because they're very challenging and make me need to think a lot, and they sort of get my brain working.
I like most about math is that everything in math defines the natural world, such as you can calculate the rotation of the planets with math.
My favorite thing about math is that it makes sense.
I really also like working with like riddles, math riddles, because they make me think.
The thing I like most about math is I get to write on the chalkboard, and I like doing adding math facts.
The challenge. I like having a challenge in math, and it's fun to see me computing all the numbers, and it's rewarding to get an answer and getting the answer right.
I like math because I can be with like other groups, and it can like help me instead of me thinking about everything, and they can help me if I ask them something.
So my favorite thing about math is when we do enrichment problems, and the reason is I really like challenging myself, and I love learning new algorithms and new methods, so it's really fun.
My favorite thing about math is that we can do number bonds because it's easier with the numbers, and because you can have the tens and the ones.
I like algebra because it has a lot of use in real life, and it's about finding other variables based on what you know.
The thing that I like most about math is problem solving, and I like doing algebra because I can figure out what I don't know using the information that I do know.
My favorite thing about math is when we do the vertical tens and ones chart because it's very fun to regroup the ones and tens.
I like the enrichment problems because they really make me think. You use it a lot in real life?
That there's lots of different ways to do it.
My favorite thing about math is that you learn something new every day. And I like this because you're able to challenge yourself.
I like that you can manipulate data in the way you want it to in a graph. So it looks like, in the graph, it looks like what you want it to look like, and you can use it to your own advantage.
I like the word problems the best because they're the hardest and it's fun to be challenged. Multiplying because it could help you in life. Like if you're a cashier, you have to add up the money and stuff.
Nothing's really ever the same. It's all a challenge, but we do something different and interesting every day. So it's never going to be close to monotonous, but there's always something new that you can do, and it's always fun.
My favorite thing about math is that I get to explain my thinking in written thought, and that everything becomes less complicated when you can show what you're actually thinking on like a piece of paper.
I have no doubt in my mind that these kids are learning a lot.